Okay, let's talk about a problem I think we've all run into. You've got a perfect 1080p video source,
Right.
but the screen you need to get it to is, I don't know, 300 feet away. Your standard HDMI cable just gives up after, what, 50 feet?
If you're lucky, yeah, it's the classic install nightmare. You start looking at these incredibly expensive active cables or trying to chain things together. It's just a mess.
Exactly. So today, we're going to dive into the other option, video over IP. And we're looking at one specific device with a, well, a truly terrible name.
It's a bit of a barcode, yeah.
The NTI ST-IPHD-LCUK.
And that LCUK part, that's really just to say it ships with a UK power plug. The tech inside is what matters. The mission here is to send or multicast your digital video and audio over cheap standard CAT5E or CT6 cable.
Okay, but hang on. Video over IP, that's not exactly brand new, is it? Isn't that just a fancy term for streaming?
In a way, yes, but it's a dedicated hardware solution. You have a local unit, that's your transmitter at the source, say your PC, that converts the HDMI signal into network packets. Then you have a remote unit at your screen that just converts it back. It's designed to completely replace the video cable.
So it's basically a real-time translation service for your video signal.
Precisely. And because it's using IP, you're not stuck with just one source to one screen. You can do a simple point-to-point setup.
Like a super long extension cord.
Exactly. Or, and this is where it gets interesting, you can do point-to-many.
Okay, point-to-point I get. Projector at the other end of a conference hall.
Yeah.
But what's the use case for point-to-many? Who needs that?
Think about a sports bar with 20 screens. Or digital menu boards in a restaurant. You have one source, maybe showing the big game. You broadcast it once. Every receiver on that network just picks it up.
And the range on that?
It's 330 feet, standard. But you can actually cascade manage network switches and push that signal up to 1,000 feet if you need to.
That sounds amazing, but I feel a but coming. You can't just plug this into some old Linksys router from 2005, can you?
For a complex setup, no. If you're doing a simple one-to-one, a cheap unmanaged switch is fine. It'll work.
Okay.
But the second you add multiple transmitters, you absolutely need a managed switch. One that supports VLANs and, crucially, IGMP.
IGMP. I see that acronym everywhere in networking. Why is that the make or break feature here?
Think of IGMP snooping like a traffic cop for your network. Without it, a normal switch is just, well, dumb. It takes that high bandwidth video data and blasts it to every single port.
Whether it's a TV or not.
Right. It doesn't care. It just floods the entire network.
So your whole office network slows to a crawl because the switch is busy shouting video data at the printer.
That is exactly what happens. IGMP makes sure that video stream only goes to the ports that have a screen attached and have actually asked for it.
That makes perfect sense. Okay, let's talk about picture quality. The box says 1080p, but it also mentions MJPEG compression. That sounds a little old.
It is. And that's the big trade-off. For moving video like a movie or sports, MJPEG is actually great. It'll look perfectly crisp. But the compression algorithm saves bandwidth by discarding some fine detail. So if you put a static image up, like a PC desktop with tiny text,
It's going to look fuzzy.
it's going to look noticeably fuzzy, yeah. It's not your monitor, it's the compression artifacts.
Got it. So it's perfect for digital menu board, but terrible for showing a quarterly financial report in Excel.
That's the perfect way to put it.
What about lag? Latency. If I'm using a mouse on the remote end, am I going to feel that delay?
You are. The spec sheet says the encoding delay is about 33 milliseconds at 30 frames per second.
Which doesn't sound like a lot, but what does that actually feel like in the real world?
It's about a 2-frame delay, so if you're just watching a video, you will never ever notice it. But if you're playing a first-person shooter or doing graphic design,
Forget it.
it'll feel like you're trying to move your mouse through mud. It's definitely for passive viewing.
Okay, so keep it to passive consumption. Good to know. And just to round out the specs, it's HDCP compliant, so protected content is fine. That's, what, $195 a unit?
Around there, yeah. Which, when you compare it to the cost of rewiring a building for long-run HDMI, is very effective. You just have to remember the golden rule.
Which is?
This is for your local area network only, LAN only. There's no WAN support.
Meaning you can't, like, send a video feed to your branch office across town over the internet?
Nope. It has to stay within your local network to function. It's a closed-loop system.
You know, hearing all this,
Yeah.
it really makes you think, if standard Ethernet is this capable and this cheap, for moving high-quality video around a building.
It's that convergence of AV and IT we're always talking about. Everything is just becoming data packets.
Right, so as video just becomes another type of data on a generic cable, are we actually watching the slow death of the dedicated video cable? Is HDMI just a walking dinosaur?
Yeah.
Something to think about.